Hello, my name is Justin Hickman. I'm with GwtDb. Today is Tuesday, May 23rd. We're basically going to be catching up with the changes that I made since the last stream. And looks like my hair is all messed up today. That's fine. I am going to switch over to my IDE. Turn down this music a little bit. All right, so I made quite a few changes. I was basically just catching up with where we left off with the different kinds of searches and the indexes. We created basically this index 2, which will eventually replace the other index that we're currently using. I think right now this is the primary one that we're using in the GWT database, but we're going to be switching over to this because it's got the queries a little bit better, including with the index builder and so on. So here I have the ability to pass in a type. Haven't figured out the text one yet. Probably get to that at some point. I am not sure. But all of it relies upon this index builder, so that whenever you're building the index, you pass it a list of all your fields, what types they are. If you pass in a field name without the type, it just assumes ascending, which is perfectly fine. So if we take a look over here, we can see that we create this index on first name and then age ascending. I created a value extractor, which is basically the ability to pull values out of the bean. Right now I'm just using the reflection one, and that's only for the JVM purposes. Once we get this on the GWT side, this is going to be like a JSON data extractor or JavaScript object. So whenever it has the JS object, we'll be able to pull the values appropriately. Haven't written that part yet, but that should be fairly easy. So right now I'm just doing queries directly on the index, and looks like I'm re-indexing. Let me take a look at that. Whenever you re-index, you can re-index it with a collection. So then whenever I look at, it looks like the re-index in the base just clears the tree, but then each subclass, like unique index, will just go over the other data, create a key for that record. And because this is a unique index, all I'm doing is grabbing the value extractor, getting the value for that record, and whatever keys that I have. And I am not entirely sure where that came from. And that's from the other field. That's right. So for a multi-field composite key, or index, we should be able just to grab all of the other fields and extract the other values for all of the fields. We pass it to the key values. We throw on a new key. The other nice thing about the unique index is that it's going to assume that there's going to be a single value per item in the other tree, whereas with the other index, I didn't have a good name for it. It's a non-unique index. With that one, whenever we're indexing for the data that's coming in, we are creating the key. We check to see if the tree contains the key, and if it does, we grab the value from it, which will be a list. So the big difference is that the tree for the non-unique or other index is a string, or just the key to the a list, and that has the ability to grow. I can flatten the list, looks like if I look at the flatten here, all it does is return the stream, which is very nice to be able to see all of the data that's in the index. Let's go back to this. What other changes did I make? I made some changes to the operators. So let's take a look at the operator. All right, so for the most part, I started creating some more of these operators, and this is based upon the different logical operations that we can do on data. So we can do less than equal, greater than equal, and so on. This one's an in. Haven't done that one yet, but most of these are just value operators. So if I take a look at the class hierarchy for that, you can see that I have greater than equal, and greater than is a subclass of that. Less than equal is a subclass of that, and then we have equals. And the big thing with the value operator is that we have the ability to get the end and the start value that's going to be needed for determining the range on the index. So if we are creating a key based on first name and age, and then we come down here, so this selector, we are creating a selector based upon first name, Noreen, age, less than 46. So if we take a look at the less than operator, true, less than or equal, we have the start value and end value, and the start value is going to be the minimum, which is basically if we're looking at numeric, it'd be like integer dot min value. Because this is a less than or equal, it's going to go from the min value to the current value. And then I added for the value operators a test method, which is basically a predicate of that value. So then we would be able to just compare. And looking at the compare, it's just checking to see if it's comparable, and it returns the comparison value of it. For less than or equal, it's 0 less than or equal compared to that value. And then less than is just 0 less than that comparison value. So that makes it a little bit easier, because then I would be able to actually use the operator sort of like a command object to be able to test all of these values and figure out the minimum and maximum range. So let's take a look real quick to see if there are any other changes. I'm going to switch off my camera real quick. That way you can see the diff side. So there's the base index. We have, see, I haven't implemented the in operator yet. It is just an operator. It's not a value operator since it's going to have multiple values. I haven't really figured out how I'm going to do that one yet. It could just require, like if you were to use the in operator, it might require the query planner to split out multiple selectors so that we would be able to do like an intersection or a union of all of those searches. So that's that one. Index builder. This one's pretty simple. All it does is whenever you create the index, it just sees if the index name is nullable. Otherwise, it just grabs the all of the fields, keys, and all of that. And that's basically what MongoDB does. If you remember, whenever I created these indexes, I was able to basically create an index with the ascending, descending, the type, and it just concatenated all of that together, and that's the default name, because all indexes are going to have names. In Mongo, I don't think you can change a name. Yeah, you can only delete an index. You can't actually modify the index once it's actually there. Probably don't need to worry about that too much on the Gwt database side. So this key, oh, this is a important one. So I did make some changes to the key class. Well, I guess I didn't do too much on it. I thought I did, but it doesn't look like I did. This could be an index out of bounds exception, but I'm relying upon the plan, the query planner to make sure that we're only comparing apples to apples and so on. That way we don't get any key values that are incorrect. It could be null, but we already checked for null, but the key values on both sides should be identical. We shouldn't be using a particular index if it has a different set of fields that we're querying against. So then going back to the test. So I was having some issues with the less than or equal. So basically it requires us to further filter the data that's coming back. So if we take a look at the selector, we call search on that selector. Let's take a look at that implementation. So this creates a search range from that selector. And if you remember, the search range is basically checking to see if it's an value operator, and then grabs the start and end value for it. Otherwise it's null. Descending, I swap the values, so the end value is the start value and start value is the end value, and vice versa. Whenever it's ascending, we just do it this way, and then we just set the start and end keys for our selection range. This doesn't handle the non-inclusive less than or greater than operators. So in order to do that, we do the search with the start and end, we do inclusive, and then we map it to the values. And this is still a stream. We have the ability to flatten that stream because in the case of the non-unique indexes, we have to be able to flatten all of the lists, because the tree value here is a list, so we need to flatten those lists even further into a single list of values. And then we call filter on that stream. So this will allow us to continuing to filter. So we've already reduced the number of items that we're getting back by giving it a best guess. This is the range that we want to look in for the entire tree. So then from that collection, we further filter based upon the operator. So let's take a look at this one. Let's collapse that one, make this a little bit bigger so that you can see it. So in here, we pass it the predicate, which is basically just the oh, well, hold on. Let me take a look at that. This is the filter. I was looking at the wrong thing. That was the reference pipeline. All right, so the filter in here is basically just grabbing the operator for this particular selector, and then it's able to grab the value and call test on the value. If it's not true, it just returns false. Otherwise, if it's gone through all of the values here, and the operators, it'll just return true, because we assume that if we've passed this, of course, we need to figure out the non-value operators like the in. So we'll have to figure that one out eventually. And then we just collect that into a list, and that's about it. So let's take a look at one of the outputs here. There's my run. All right, so here This one looks like I'm only passing in the 3 values. So if I were to first name index debug, what does that do? I can't remember. That does the that does the graph viz. Let me grab my browser real quick. There we go. All right, so this one is only creating a tree with the 3 values because we knew that Noreen existed in our CSV 3 times. So we basically just filter that person list to just those 3. That way I have a smaller set of people that I'm looking for. So here I can actually test the greater than or equal, less than or equal, and it should be accurate. So I don't think I have any tests for the let me go ahead and create tests specifically for the operator. And operator test. Yeah, I could probably just do the same thing here. That way we start with a known value. Noreen has ages 12, 46, and 93. So here's a pretty nice thing to notice. Let me just execute this. That way we can see this a little bit more in isolation. And then if we were to first name index debug, this will actually be kind of cool to see. So whenever I come in here, I can grab that. It should be identical to what we had before. Oh, that is code. I did not copy that. Hello, copy. There we go. Yeah, that was identical. All right, so notice that it's all Noreen. Of course, I could probably add another name in here. But if I were to change this index so that the age is descending, and then re-execute this, it will basically create the keys appropriately for a descending age. So whenever I paste that in, you notice that the keys, it's going to be ascending, even though there's only a single name here. It will be ascending for the first names, but the ages, you can see that we have a descending order. So then it really depends on how you want to do the queries. And I need to make sure that both directions work, because whenever we do a greater than 46, we obviously don't want to return 12. If it's going from left to right all the time, we will need to be able to start the opposite direction for that. So let's go ahead and try that out. Let's do first name index, search, selector, create. And oh, yeah, I need to be a little bit more consistent on this because the index builder, it's calling create at the end, whereas this one is basically like a factory method. So yeah, I need to change that a little bit. Wonder if I should just use the same builder and create methods in here. mean, technically the selector is its own builder, so I could public. Yeah, select create doesn't do anything then. I don't know. We're gonna have to figure that one out. I'm gonna put a to do on that. All right, so here we should be able to add a field. Let's search first name. And the value is going to be Noreen. And then the age less than 46. And of course we need to parameterize this with a person. There we go. And what is the problem there? Oh, wait. I did that again. It needs to go after the other period. There we go. All right, so then whenever I do that, result, I can assert goals. I think it's that one. So the people, so that should be one result. So if I refresh that, run it again, it should actually pass. Yep. All right, so then less than or equal. That should give us 2 because we have 46 and 12. And of course, right now I'm not doing anything with sorting. Eventually, I should be able to execute a search with a sort, but I'm not sure if I want it on the index side or the database side. I am not sure. That one worked. So if I print that one out, we should at least be able to see the other 2 records, and that's going to be Noreen age 46 and Noreen age 12. So that one worked. Operator test. And of course, if we did ascending here instead of descending, this should continue to work. We should probably do these as parameterized tests, to be honest. How would I do that as a parameterized test? The parameter. Oh, did this this class didn't have a parameterized test before, did it? No, it does not look like it. Operator test data. Static stream of argument. Operator test data. Return stream of arguments of, and this is where we can actually create our arguments. And let's see what we want to change for each one of these. I'm going to split this window. Let's take a look at this. So I probably want to do the ascending and descending. So then type, this is going to be H direction. Oh wait, this is the wrong place. This needs to be right there. So then I should be able to... Actually, I also like to have names. Test name. And you'll see why here in a little bit. I didn't do that on the previous test. Only on a couple of places did I do that. And I'm probably going to do the same thing here. Only load. Maybe I should load the whole list. Yeah, let's... I don't know what the performance of that's going to be to like, I guess it doesn't really matter with a unit test because it's not a mission critical system. All right, so then the age direction is right here because we want to be able to test less than. This one doesn't really matter. Because I kind of want to execute all of these for each side. Just to make sure that they have the same results. One will be a little bit more performant than the other, but they should return the same values regardless of how we sort the key. So I might actually just double up this test based upon the other direction. So it's like arrays as list, type.ascending, type.descending, and then for each one of those, age direction. And then I can get rid of this. Then we can just execute that test twice for each sort direction. That should be fine. All right, so I don't need that anymore. What are the other parts that I want to look for? So we did the re-indexing, and we need a result. I can probably do the first name as a argument, just in case we want to search for other names. And this will probably have to be an operator, age operator. All right, so then if we want to check for Noreen, and we want less than 46, then we'll need to figure out what the expected results going to be, because now we can do the comparisons here, the assertions. Right, and that is going to return 1. Wonder if I should create like an array, new person, Maureen, 12. Oh. Guess I don't have a convenience method for that. I guess I don't need the expected result size. If I have the expected people, expected result. Of course, I am only going to be testing the age and the names because we're not looking at last name. Get rid of that. All right, so then expected result size. And then for each one of those, yeah, that's going to be a little bit more difficult. Yeah, that's going to be a little bit more on the other difficult side because of the fact that we don't know the order here. Let's just do that for now. We can expand it later to see if it actually works. Execute that test. And that one, no explicit conversion. Integer to, oh, it's because I still have in my test arguments an integer. There we go. So then let's do less than equal, less than or equal, and this is going to be, oops, 2 people. And of course, you remember that we're testing both directions. So this is doing the index ascending on age and descending on age. And we just make sure that we get the exact same results for each one. I can dive a little bit more into the result and compare with the one that I passed in. It might be a little bit more difficult. I am not entirely sure how I could do that because I would actually need, I guess I can, I mean, this might be kind of weird, but I can create the same index and then I can fetch from the index as my test data, but that's gonna be kind of weird. Would it be weird? Yeah, probably. Probably can't use the class that I'm using to test in the test itself, because then if it's failing in one spot, it could be causing another failure, which could be like a false positive. All right, so then we have those two, and this is actually because of the fact that we rewrote this to re-index the entire person list. This tree has over 1,000 people. I think it's exactly 1,000 people. And then it's finding just the ones that we need in there. That works pretty well. And of course, I could change this to being the, right now I'm only passing in the operator here. I can change this because whenever you're not using an operator, it just assumes the equals operator as the default, which makes a lot of sense because if you're searching for first name Noreen, it's just going to be the same as an equals operator. So if I were to change this to the first name operator, I can do equals here. And this is why I had the argument, the very first argument as the test name, so that whenever it's printing out all of the tests that ran, it would give me a little bit more detail as to which test it was, the test data argument. Oh, that's kind of weird. That's kind of bizarre. Wonder why it's doing that. Wonder if that's on my side. So we have equals, less than, or equals. I should probably do the other greater than, and greater than or equal. So let's go ahead and repeat those tests. Greater than or equal. And this is going to be 96, and this is going to be 96, right? Because we only have one greater than. There we go. And let's just make sure that this is failing. Let's put a 2 in there. Let's make sure that it's actually testing properly. Oh, it's not. So oh, it's because I'm only checking the size of the list right now. Yeah. So this is kind of pointless. I mean, I guess what I could do, because I know that I'm grabbing the person list, unless there's 2 people with the same first name and same last name. I don't know if any of that exists or not. I guess I can test in Mongo, honestly. First name, or wait, no. How do I do that? So I want everybody, but I want to basically group. Can I just do a group? Yeah, I'm not entirely sure. I'll have to figure out how to do that in Mongo, because I kind of want to know if there's any repeats of, I mean, is first name, age in my collection for the other tests unique enough? Key count names. So this is counting names. This is basically just keeping a tally of all of the first names, ignoring the age. So let's just make a, test out of this. So for the person list, for each one of those, actually, I want to stream, I want to map, create item or person, create key. This is going to be person dot first name, person dot age. That was weird. It jumped like that. Person, or this is the key. There we go. So this basically just creates a key for the person, first name and age, and then for each one of those, it just checks to see if the this hash set already contains that key, and throws an assertion error if any duplicates. I should probably print out the result. Looks like I know that this one will fail whenever you do just the first name as the criteria. No. Does my key not have an equals method? Oh, I did not implement an equals in a hash code, so my keys aren't even bothering. All right, let me just do it on the keys collection. There we go. That one should fail now. That was not very helpful. Kind of want to see the name and basically the other person that is non-unique. So if not fail, non-unique key found. Why is that always true? How could that possibly be true? That's not always true, is it? E2 person. This is creating a key 2 of the person. I don't know. That one shouldn't always be true. Doreen. All right. That's fine, because I also need to put the age back in. This one should be successful, assuming that there's no duplicate first name. Oh, Doreen 97. All right. Unless it's failing on the first one for some reason, and I completely messed that up. Yeah, Doreen 97. It is failing on the first one, so why is that always true? This key is a key to of a person. This keys is a hash set of the key to of person. How could that possibly be true always? I have no idea why that's saying that it's always true. Oh, duh, because the list is empty. If it does contain the key, God, why did I mess that up? Yeah, that makes sense. All right, so I need to get rid of that. And that one should be successful now. And let's look at the first person in the list that fails that. And it's Aggie. So let's take a look at that data again. Aggie 87, Aggie 89. Yeah, so that's the first repeated first name. Cool, so that does work. Person, age. So now we at least know that the first name and the age is unique, which pros and cons. Because of the fact that we're using a non-unique index, it would be nice if some of these were repeated. So I'm wondering, should I create some mock data in here? Just picking some random name. Isa. There's an Isa right there and there. So I'm gonna do a age 56. Isa Jackson. Now there's 1,001 records. So we should probably check that one too. Ah, see, there we go. That's good to know. That's very good to know. Where did my test go? Okay, there it is. Let's disable this test now. It was only for just validating our test data for this, but because of the fact that we're purposely modifying the test data to contain an issue, it'd be nice to be able to see that. So now arguments of greater than with duplicate key value. I don't know what to call that. All right, so what do we call it? Is Isa. The first name is Isa. I don't know what I said before. Greater than doesn't really matter. So this one should return 3. Even though we have 2 of the same age. We have 256 and 151. Six, 56, and 51. And hopefully that works. Let's go back up here and re-execute that parameterized test. Looks like our frame drops have settled down. Ooh, that broke. Oh, it's found unique key. That's weird, because I'm not making it unique. Oh, it's because of this before each. Well, that hurts a little bit. So this is a B tree. Do I need this B tree anymore? I don't think I need that B tree anymore, because I'm creating a new B tree in each test. So that makes sense. So I don't need this anymore. Well, that seems to have worked. Of course, we need to start testing some of the other data. Because right now we're only testing for the expected result and the other size. Not entirely sure how to validate two collections of different objects. I mean, I guess we can modify the person object. Do I have an equals in here? No, I do not. Well, be kind of weird, but I can do an equals. We do it with the other wizard and use just the first name and the age. All right. So if I were to compare those collections, the JUnit assert equals should go through and see if they're the same list. Oh. So it takes sorting into account. So it probably means that we need to have the same sort. How can we do that? Pairing. Yeah, so let's compare person first name, then comparing person age. So if we were to sort the expected result, and of course this one can go out here. That should at least validate that the sort is the same. All right. Marine age. Oh, see, that was that was probably an issue with my test. The arguments. So this is greater than. So if I do greater than 46. Oh, I just had the age wrong. So it's 93, not 96. So that was my problem. Okay, cool. So now we're actually testing to make sure that the collections are the same. Even though it's a different equals method, I could probably pull that out into a non-implementation of the equals. I should probably do that. First name, age. Of course, now this is going to be a little bit more complicated. Do probably need expected result iterator. So if the arrays are of different size, it'll throw a assertion error there, and we won't even get down to the this side, which would have the out of bounds exception if it wasn't the same size. So now we just want to assert true. Expected equals with only the first name and age. I know it's a little bit more complicated, but if I were to ever want to create an actual equals method on that test bean, this will at least give me the ability to do so. All right, so that's cool. And this one also validates that we can receive two ISAs with the same age, even though the key is a combination, and it's holding on to both of those values. If I were to debug that, if let me actually grab this equals test name. I'm going to just print out the result, because this is going to have their last names in there too. And it prints it twice because, again, we are testing the age ordering, ascending and descending. So we have Isa Marskell, age 51. We have Isa Baxter, age 56. And then we have Isa Jackson at 56. So that's cool. So it was able to flatten that collection. That is perfect. I have less than or equal, greater than or equal. That one's just testing that key, but I kind of want to see what other operators do we have. I cannot recall. Obviously equals already works because we are using the equals operator on the name. This one might be kind of interesting. Arguments of. What if we did anybody that is greater than or equal to Isa for the name, and then the age is going to be anybody. Maybe I can do greater than 60. I have no idea what this would be. So of course this is going to fail, but it might be kind of interesting to see. Oh, that's because it's an empty list. Oh, no, that's not it. Using greater than or equal on a string key. I just had the wrong arguments. All right, so there are 206 people. I don't want to type all of those in. So let's narrow this gap. Let's see if how many people are above 90. 47, wow. Some old people here. $22. I think I did 0 to 100, didn't I? Do we have any 100s in there? I should probably just look at the test data just to see. Obviously not greater than. So greater than or equal. Yeah, let's just do equal. Oh, 7. I'm trying to find one that has a few number of people in it. Yeah, that's more people. Yeah, let me just look at the mock data. How many 5-year-olds do we have? That one's not too bad. I should do 5-year-old, comma 5, end of line, regexp. All right, so we have a Belina. Oops, did not mean to do that. Oh, this one will not be in there because if you remember, we're also doing greater than or equal to Isa. So I should probably do 2 of them. I can't do that. How many 5-year-olds do we have? We have Bordy, Vince, Marcel, Camilla, Susie, Cynthia, Christabel. So yeah, we have quite a few. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and that's it. So we have 14 total people in this database that are age 5. But the names that are greater than or equal to Isa are only 4 of them. And let's just figure out who they are. Well, there's Vince. Vince. 5. Marcel. Yep. Camilla's not. Susie is. Why do I have 2 Vinces here? Did I type something wrong? Mitri, Reginald. Reginaldy. That should be it. Because there's Bobina, Gail. That is less than I. Okay. Yeah, that looks correct. So if I were to execute that, that one should be successful now. Nice. And I could probably do... Yeah, the next one is Marcel. Let me do Mark. This will be after, so this will not include Marcel. Nice. So if I added Marcel back, it should fail because it's like, hey, there is no Marcel in this list. Yeah. So we have the incorrect number of people. So that's pretty cool. So this is actually working really well. So let me comment that out so that I can have that as a win. What other? We did equals, less than. We just haven't done in because we haven't implemented in. Let me just rerun this, make sure that it's still functional. There we go. Let's run all of the other tests. All right, cool. Cool. All right. So I should be able to probably clean that up. I still have a debug in there. Don't think I'm doing anything with this anymore. Yeah, it doesn't look like this one is used for anything anymore. Because the operator test... Is that doing anything? Let me just replace it. I mean, technically it is, but I think the test that we just created does all of that stuff already. So I can get rid of both of these, actually. All right, cool. That will work for me. So I am going to commit all of this stuff. Yes, we will have to get rid of some of these old values. Yeah, I don't care. Added more operators, added index search operators. I don't really care about my own internal commit messages, as long as I can figure out what they are. We will have to expand that at some point. So let's switch gears a little bit and let's see if we can replace the indexes that we have on the GwtDB side. So let's open up our main entry point. because we haven't even implemented all of this yet for the Gwt side. We have a new person, and this is a different person object. This is one for my application itself. Would be nice if I had the same database of people, make it a little bit more convenient here. But the CVS isn't available on the client side. Yeah, I mean, this should work. Let's go ahead and do a clean install real quick. That way it executes all of the annotation processors. Here we go. Yeah, let's just see where it fails. It shouldn't fail anywhere right now because this selector, I think this is the same selector, but the index is different. So we do need to take a look at the index. So before we get into this, yeah, we need to switch out our index. Been a while since I've looked at this code. So this is the implementation that is auto-generated with the annotation processor. Does the serialization, deserialization. All right, I guess it's over here. All right, so instead of create index, we're probably going to need a little bit different. We also don't need this store anymore, to be honest. Is this a B tree or a B plus tree? This is the B plus tree. So it's good that I at least replaced the B tree with the B plus tree. So we should be able to get rid of that soon. I guess technically we don't even have to do this. Of D. Instead of using a B tree here, we could just create this as an index. And the index is going to be on the key. This is going to be a unique index. trying to think of how this is going to work. We only want the ID, and let's just sort ascending. And we do need to have a value extractor. So we have the JS interop one. We haven't implemented it yet. We also have the reflection one. Basically going to do it very similar to this, but with property maps. And this is our connection to the Gwt client side. So it's fine that this is going to have knowledge about that, because it needs to know about the JS objects anyways. All right, so how are we doing this? I cannot recall. So when we are posting an object, yeah, I don't know how that works. Let's just go through this again, because I think there was like a wrapper type, but I cannot remember. So that extends base GwtDB. That has a strategy, and that's going to use a JS object strategy. That's fine. Ah, here's the serialize, deserialize. So I think that's going to be a little different. Let's figure this one out. Extractor. All right, so if I were to do this, let's go ahead and implement the other value extractor. Let's take a look at the reflection one versus the JS interop one. So we basically just need get a value from that path, and get value from a path. It's splitting the path. So yeah, I can do the same sort of thing here. That returning? Yes, property map of D? No. Somewhat object. And this is going to be a path. JS property map of object. Okay. Okay, so I didn't call it recursively. That's actually pretty good that I didn't do that. So I am going to, if object or map is null, turn null. I know I'm repeating. I can refactor this later. All right. What am I getting? The other field. Oh, and that has to be some sort of object. I don't know if you can get a property map off of like an integer or something, so that might cause a little bit of an issue. Hmm. Yeah, I could probably do it like that. And of course, I didn't need to rename that. Yeah, that should be correct. I don't know what would happen if one of these paths are not an object, but I guess if you're trying to search for that path on a path that doesn't exist like that, you're gonna have an issue. All right. Don't need that anymore. I'm gonna assume that this one's implemented, so let me remove that to do. We'll see if it actually is. All right, so anywhere that we're using store. I don't think I need that anymore. Yeah, this is used in the index. I'll come back to that. Wonder if I should return all somehow. Maybe I should just do a stream. And of course, this is going to return a stream of D, right? That's not what I wanted. So if I were to get all stream map tuple get value return that's a oh, I need to flatten it, right? And then flat. How did I flatten that before? Oh, I just flattened the stream. Sure, that might work. All right, so then I call stream on that. Let's get some data into my store first. All right, so here's a post ID index. Yeah, this is just re-indexing. I guess I don't have the other methods for adding and removing items from an index. I guess I need to, right? Guess I need to do those first. Realized after I got in here that I need some ability to add and remove items from the index, because anytime that we're re-indexing something, we need to be able to do that. So if, like remove from indexes, it's going through each index and it's calling index.remove on that object. So, and we haven't implemented that yet. So let's go ahead and let's do that. Let's open up our first index here. Let's grab the remove method signature. Yeah, this is the index before was just assuming that it was a JS object. I didn't like that. I probably need the ability to add. So then in the base index, we have to implement the add and the remove. And how are we creating the keys? Create key on that object. There we go. Tree add, create key, object, and then object. Right? And it's B. Oh, yeah. Remove makes sense. Not so much on the add side for being in the base class, because if you remember the unique index one, whenever we're re-indexing, we have to actually do it a little bit different. is my method signature for reindex? It's just passing out a data collection. And it just so happens, yeah, that makes sense. Because in this particular case, I'm saying that the base indexes of D and D. So D is the in data type, and this D is the one for the type of the value of the yeah, it's kind of confusing. The value type of the B tree. In this particular case, with a unique index, they're the same, but in the non-unique index, I called it other index. I should probably just non-unique index. Then implement add. Should probably move this stuff out. So that is the same as up there. And that means that this is going to be the same. And I'm going to call this one record. Consistency. Gotta have a little bit of consistency. All right, I do need to probably run that test again. Because I did refactor some of this stuff, so I need to make sure that didn't break any of the tests. Okay, that still works, good. All right, so that was the non-unique index and then the unique index. Those are pretty simple. So then back over here, I wonder, I guess I should just do a JS object here, right? This is going to be a value extractor specifically for JS objects. So the first thing that I want to do, oh, this is getting me the previous value. Wonder if I should do the same sort of thing where it returns the previous value. That'll be a little bit more difficult on the non-unique index because it could return a collection. Which I guess in this particular case could be the same, but we already know that this is a unique index for the IDs, so that should be fine. I don't like that. I'm not a big fan of this. I don't know if this is going to work, but it might be kind of interesting to see. A little bit wider. All right, so that'll give us the existing records. Looks like I'm probably getting some frame drops again. All right, so that was the existing. So basically, if there's a previous value, if existing is not equal to null and existing is not empty, remove from indexes. And it's really just the first one. Then result, add to indexes existing, or not existing, but JS object. Why? Oh. It's because I need the return value there. Okay, I get it. All right, so the stuff down here we're going to remove once we figure out how this is going to work. So that too. So this is the other new stuff. This is the old stuff that has to go away. I don't think I'm running the server right now, so let's go ahead and get the server up and running. Hopefully this doesn't kill my frame rate. I actually wonder if it's the closed captioning. My computer doesn't really like Chrome too much, and I can only get the stream closed captioner with Chrome. Wasn't able to get that to work with Firefox, I don't think. I don't know. Firefox. I think it broke it. Yeah, I think I had broken it because I started the closed captioner with two different sides, two different browsers. So it's not actually capturing text to speech. Yeah, it doesn't seem to be doing it anyways. So I think I lost closed captioning. That's fine. Sorry for anybody that needs closed captioning, but that is no longer a thing that I can do on this stream. All right, let's take a look at our Gwt startup here. I think it might be Chrome. I don't know, because Chrome seems to be really flaky right now. And let's see what we got. We only care about the console. All right, well, there's a lot of exceptions here. But I don't think it's actually up and running yet. No, it is not up and running. Still loading the main. Like, it's not compiling for some reason. Go. See what this does. All right, so that's doing a lot of failures. Unique constraint violation. But this, oh, this is B plus tree. I have multiple people with the same key. Found duplicate key. That's weird. Yeah, I'm not entirely sure why. Because I have a key here. How many times am I adding that? So on here, I'm creating an index. Let's ignore that. You have the DB, and then we post Justin, and Justin has oh, I wonder if it's because I'm not actually removing it ever. Probably should go through the other parts to make sure that those are removed. So I'm assuming that this is coming from... No, this is the other indexes. Yeah, I'm gonna have to I'm gonna have to redo these all together. All right, so let's do that. So for the indexes, how many create indexes do we have? We only have really the one. Let me comment that out for now. So let's not actually use that index. There we go. Not yet implemented. We'll figure that one out later. All right, so the DB create index is going to be a little different now. This is going to have to take like an index builder. I guess that's the only thing that I have on here. It's not going to be a unique key. Yeah, and I guess that's the thing that I fixed before, is because I was just ignoring duplicates before. So that's actually good. Do I not have the ability to specify a name? I should probably give the ability to name this. Oh, I do. First. All right, so now create index is going to be a little different. I don't know if I need a promise or not, but I can go ahead and create one. Index builder of D. And the only reason I'm taking the index builder instead of the index is because I want to slap on the value extractor last minute. So here, create index. I'm going to return strategy, create index, and index builder. Okay. That. And then this one. Yeah, that's going to be a little different. Oh, crap. Because I guess before... Was that working? Yeah, so even though these indexes were of type D, it was hard-coded on the inside to use a list of J objects as our B tree, but this is going to be a little different. So I have a little bit of extra stuff in there. Because I have to actually store extra junk for the serialization, but this is actually returning the bean. How was I just doing that? Let me take a look at that serializer, deserializer again. So here we're wrapping the bean. We're setting the ID, setting the revision. Grab the writer, building a context. We're serializing from the bean to a JSON object. And then we're just grabbing the value, which is the JS object of the bean wrapper. Yeah, this is the bean wrapper. Ah, boy. Let me comment that out for now. I do need to comment out. This has to be a person. So over here, I actually need to put a breakpoint somewhere. In the other post method, I do want to see what this JS object is. I'm having to remember how all this works. I'm pretty sure that this is the wrapper. So let's go ahead and refresh that, and this will be the bean wrapper, and it's going to have like the ID. Yeah, revision and data. And then data is the actual object. Ugh. Well, that sucks, right? So how's that gonna work? How do I create an index on that? Because all of the paths would have to be modified because we're indexing, having to slap on an extra path argument. Ugh. Yeah, and even here, it's like we're adding to the index, and this is the bean wrapper. So then whenever we get the objects, let's take a look at that. See, like right here, deserialize. This is not type D, right? I'm confused. Oh, I don't think that's right. Because this store was holding all of the types, and it wasn't. I don't think this is holding the wrapper, the bean wrapper, right? Oh, it's adding the bean wrapper. I don't want to see how this works. It's been like 3 weeks ago since I wrote this. 4 weeks. I don't recall when I wrote this stuff. Yeah, so this is the bean that's going in. Oh, so it pops it off of the, so they'd serialize and deserialize. Yeah, that's going to be a problem now. Because we are serializing the person bean to a JS object containing the wrapper. But then whenever we deserialize that JSON object, we're assuming that's still in the wrapper. We deserialize it, and this deserialized is the bean wrapper. And we get the other data from it. We reset the ID and revision and return the data without the other wrapper. So the wrapper is only known inside of the serialize and deserialize, but that's going to cause problems with our indexes. How did that work? So our index before, I might have to have a thin layer on top of the index. Like creating the keys for these. So it's like my value extractor. I'll need to have a little bit more involvement on it. I need to push on an extra path in here. I guess that's not a terrible problem. This is only used here. What package is that? So let me make this package private. So this is going to be for JS objects stored in the B trees. We need paths to assume. Need to fixes paths to assume we're wrapping inside of bean wrapper all data. Prepends the data in all paths. Okay. I can always just prepend it. So string, private static, final string, prefix equals data dot. Path equals prefix plus path. So then that always has data in front of it. Yeah, I mean, that's ugly. That is ugly, but that should work. That should resolve that problem. So then I don't have to worry about it over here. So then whenever I'm doing my searches and stuff, and it's grabbing the values for creating keys and all of that, it'll be able to basically pop off the bean, the wrapper on the outermost layer. Okay. And for this one, need an easier mechanism. Probably just need to be able to expose the create a key. Possibly. Let's put that back for now. But we would like to be able to create a key from external. Um, yeah, because I don't want to have to put the ID here. It makes more sense to just keep it in one spot as part of the index. And it's basically able to create the keys for any type using the field from the index that we specified instead of having to do it again down here. I don't like that. Yeah, I mean, that's a to-do. That's more of a fix me than a to-do. So I'm assuming the post is going to work now. Maybe. I don't know. I don't know if that worked or not. Oh, we're not actually passing at the index though. Of course, we do have the ID index. Okay, so let's go ahead and look more at this. I think on this one we just ignored it. Yeah, I'm surprised that finished because I didn't actually resolve that promise. Oh yeah, that's the other issue that we have. These are not of type D, are they? What did I do with the value extractor before? See, and yeah, that's the biggest issue. It's not of type D at this point. I guess well, we're gonna get a class cast exception there. So even if I put a D here, it's gonna give me a class cast exception. Ugh. Definitely don't need a class cast exception there. Hmm. Yeah, that's a pain. trying to do this in a way where the JS object bean wrapper is invisible. 'Cause I don't need that to be a known thing. It's just a carrier. But I do need to be able to extract that off of there. Hmm. It's not gonna work. Yeah, that's just not gonna work. How can I do this value extractor with a prefix? Yeah, that's stupid. It's not gonna work. No. Thought that was gonna work, but I have two conflicting types here. Because the objects that are being held inside of the index are going to be the wrapper beans JS objects. So they're all going to basically be this. And I implemented the index to be of type D. And of course, that's not going to work. Because they really need to be indexes of JS objects. Oops, not that one. Give me a couple of seconds. I'll be right back. Sorry about that. All right. Yeah, I'm not entirely sure how this is going to work because I basically need to convert this index. I know that the index builder let's take a look. How are we doing this? That is going to be that. I mean, once you pass the index And that's the other reason why I'm not going to have the create index actually pass an index, is because I need to be able to do extra junk to it. And honestly, I need to create an index builder, or an index of JS object. Which means that this value extractor might have to be a little different. Guess I could always use a raw value extractor, right? Can't I do that? Maybe? Yeah, so I'm using a raw type here. And that's only because the value extractor that I have is of a JS object, and it's prepending data to all of the paths, so that whenever I'm grabbing values out for indexing and searches, it's having to add the data in there. So I guess in this particular case, oops, this could be like that. That might work. May work. Let's refresh, see if we have any errors, class cast exceptions or anything. Nope. Okay, so far so good. Okay, I guess in this particular case, this is going to be problematic. Because all of the indexes are assuming to be of JS object. It's no good. Because whenever I implemented this original index, it was an index of type D, but the B tree was actually holding JS objects. So the key would be the key of person, but then the value is a list of the JS objects that hold the other person object. So here, whenever I was creating the key, I was able to extract the data portion and then grab the values off of that. Obviously, the value extractor is able to do deep fetches for the values. So I'm not entirely sure how to blend these two concepts together. Yeah, I wonder if my index builder here, what if it was able to there's really not much to it, is there? Yeah, I kind of need this to be. Yeah, I can create a wrapper. How is that working in the other places? I don't think I'm actually using indexes for anything. So for the find, we're just doing that. So we're not actually using it. So here we're just adding and removing objects from the index. But not actually doing anything important with it. I don't know. Like I said, it probably means that instead of returning the index of the data type, we need another one. I'm not seeing any difference here. Because if I were creating this of a JS object, it's really no different. I could do this. Right? Oh, it's because of the value extractor. Don't like that, but I mean, could work. Using the raw type there. May I go back to my unit test real quick? This is a tree test. Just execute that again, make sure that it still works. Yeah, and it still works. It's just that my indexes here has to be on JS object. So that's going to force it to be a create on the JS object. I'm having to do mental gymnastics here. Okay. Let's go ahead and let's do this. I mean, technically, I don't need to worry about this because indexes didn't work before. I'm just going to go ahead and remove them. Actually using that. It's fine. Okay, so this one I don't need to worry about. I'm just going to do that for now. Because this, for the find, we actually need to delegate this off to a query planner. I guess that's it. What's the usage here? It's just right here. All right, so let's get rid of that. And let's get rid of that. Get rid of that. Let's rename this one. And yeah, I know. We got the create index here that we're no longer using. All right, let's just see if we have any errors. Compilation or runtime. Okay, we do have a runtime issue. Let's see, 127.0.0.1, 876. Let's clean that. It's probably because we removed an overloaded method, and Gwt sometimes has issues with that. Let me take a quick break. All right, I am back. Sorry about the wait. So whenever I refreshed it, it looks like that error is gone. So that's good. Let me just make sure, refresh it a couple of times. All right, cool. So now let's go back to our main entry point here. First age. Okay, so in this particular case, might want to just go ahead and create this. Let's create the other thing normally. And ascending as default, if you remember. And I don't care about the name of the index for now. Kind of do want to get the CSV data from my unit tests in here. I think that would be a lot better. Using consistent data is always really good, and I didn't do a great job with making up names here. So here it's basically just I need to figure out where that not yet implemented is coming from. Not yet implemented. Oh, in the other fine. Yeah, that makes sense. All right, so what I'm going to do, I'm going to create a new class, and let's call it a query planner. And we're basically just going to hand off execution to the other query planner. I don't know. I mean, like I said in the previous stream, I don't know a lot about how the inner workings of databases work, so I am just trying my best here. Wonder if I should have a single instance. Yeah, let's go ahead and create a single instance. Private final query planner. Query planner. Can I do that? No, I cannot. Oh wait, the reason I couldn't is because the constructor didn't exist. I'm just gonna call it that for now. I need direct access because I need to be able to get the indexes and stuff like that. Oh. There we go. And a query planner. Parameterize that. All right, so then in the find method, we really just need to do the query planner, find, pass it the search. I don't know. I mean, we could pass in the extra stuff. I might eventually do that, like all of the indexes and everything. Because this is going to be an internal implementation. It shouldn't be used by the outside. And let's just make it package private. Yeah, I think I might do that. Instead of passing the database, let's just pass it what we need. And it probably should be parameterized. All right, so this dot indices, search. Wonder if I should add that just to normal index. ID index, indexes, search. Okay. All right, so here we just basically need to, for the other search, how are we doing that? Probably need the other selector from it, and I do not have this up. Here's the other selector. So basically, we're going to have to figure out how to search the indexes, which ones to actually use, I mean, we can implement this a little bit more complicated later with making, like, seeing if we can search across different performance metrics, things like that, because it might be faster to do one way or the other. But right now I'm just wanting to see if there's a index that matches the fields in the selector. Get selector. Okay. Operators. Nope. Is that correct? Yeah, because it's got the other fields too. The operators is an array list of simple entry, string to operator, and that's going to be a path to some sort of operator. So I need to stream map entry point, simple entry point, entry point, or not entry point, just entry, map entry. Key. So I need the simple entry there. What? What is going on with that? Array list. For each one, we have a simple entry. So what is this? It's just an object? What? It doesn't make any sense. Oh, it's because this is not parameterized. That's my problem. Why isn't this parameterized? Can't I have a... Why is that not parameterized? This wouldn't we be searching for person objects? Okay. I guess I may have parameterized that later and forgot to update. I don't know what that's going to return yet. We're going to have to figure that one out. So this one should now be available. This is going to be a selector of D, entry, get key. There we go. That's much better. All right, so then that's the other field name for each. All right, so that's going to have all of the search paths, not fields, but search paths. Because we're going to allow searching for nested paths. So then for the indexes, we should probably add something in the index for maybe getting the path collection for this index. Because we have the fields right here, and that should be a linked list, right? It needs to be a linked list. Where am I doing that from? Index builder. Index fields. Entry set. Yeah, linked hash map. Okay. So yeah, that's a linked hash map, which means that it'll retain the order. And order does matter. Maybe get index paths. I mean, this is returning a set, but I already know that it's a an ordered list. But I'm just going to wrap it. Oh, didn't know that the it's kind of interesting overloading. Yeah, that's fine. All right. All right, where was I? I needed to grab the index, get indexed paths. I know I can simplify that. All right, so then we go through all of the indexes. We find any index where the search paths that we're expecting based upon the operators in this selector match the ones in the index, and it has to be the same order. And I'm going to find first. Oops, introduce local variable is what I wanted. Index. Oh. It's fine. If index is present, then we should be able to do the index get search, pass it the selector. Oh, selector of JS object. Ugh. That's a pain. It's another one of those issues where I'm wrapping the type internally with a JS object, but the generic type is a little different because we will need to deserialize once it comes out of the indexes. How can I do that? Because the selector needs to be a selector. I mean, I could always pass the other. Don't like doing raw types though. I really don't. And this is not a duck type D. This is a JS object. Is there a way for me to convert the selector? Where's the selector? I want to see the selector class. Yeah, it's really no different. What is T? I'm not even using it. That's kind of weird. Yeah, so there's really no reason to worry about that. Let me just do a private cast from actually the other way around. Excuse me. I had to sneeze real quick. All right. I can suppress that. Suppress warnings unchecked. And of course, if it's not present, then what do I do? All right, so let's collapse that a little bit so we can see what we're doing. So here we just need to deserialize. So then what does find return? Oh, that's void. I'll deal with that one later. Let's just see if this is present first. So stream that. For each one of those, I need to map deserializer, deserialize. that returning a JS object? It's just an object. Why is that? JS object, right? Am I missing something here? Let's oh, I do need that to be parameterized. Is that the problem? Was that the problem? Yeah. Man, what a pain. All right. Stream, map, deserializer, deserialize. All right. Then join as a collection. And I guess in that particular case, we can just do a resolve on invoke. No, that's a get. Gotta remember how to construct one of these. See, we're not doing any kind of pagination yet. So I should probably just hold onto this as a variable, as a result. And then return, no, not return, resolve on invoke, new, all docs response, 0, result size, result that size, and I guess it's -1, right? No, total rows, that's inclusive, and then result, right? Oh, GwtDB node. I need to convert those into GwtDB nodes. There's probably code for this already. Yeah, let's take a look at this real quick. Move that over there. Split the screen here. GwtDB node. Yeah, so it's this one right here. So we set the doc. We have the key, which is it's a string, right? Yeah, string ID. Yeah, we don't have the ID. We did restore it in the deserializer though. Did not mean to do whatever I just did. Here, I'm just trying to introduce a local variable, node, of type D, and I guess it's dbutil, get ID, object. And then set doc, and this is going to be the object. And right now, I'm not doing anything with the revision. I guess I could do that though. And this is going to be a GwtDB node of type D. And there we go. That might work. All right, so let's see what happens whenever I do that search. That has a failure. Looks like I'm still using store. Yeah, I need to get rid of the store. Because we're no longer, I mean, I guess we could have used the other store, to be honest. Is there a reason why we have to do this using a B tree? Probably not. Because the B tree for the ID index should be the store here. Let's just go ahead and remove it. Don't think we need that anymore. We'll find out. So all docs, ID, index, stream. And this is no longer a key value. Basically need to do the same thing here. So it probably means that I need to split this off. But I will copy and paste it for now. So then GwtDb util get ID on the entry, even though I'm going to rename it to doc here in a second. We've already, oh, see, we shouldn't deserialize. So I guess that's a good point. With my find, I might not want to deserialize. Because that's expensive. So let's not deserialize that. This is going to be don't like this. Probably just do something like this for now. I know. I don't like it. That'll probably cause problems later. So here we want to deserialize that wrapper. And we can only include the revision. If we did that, that should work. So now it's not the store size. Oh, total rows. See, yeah, that's where I had the an issue. Guess we can implement a size. I'm gonna do the naive implementation first, then we can change it later. Then my base index size. Oops. Okay. So that allows us to do the size. So that one should be correct now. This is the ID index size. Because if we ever support pagination, we need to know like how many total records there are versus the other ones that are actually in the list, because I already have the list. I don't like this either. There's a lot that I don't like. Yes, it is. I know. Isn't that working? It's like I have to remember how this works every single time. Oh no, that should be a JS object, right? Result. If the result is empty, a reject. Maybe I shouldn't do a reject. Maybe I should just do a resolve. Null. Otherwise, I can resolve. Result get. Because we know that this is a, or not resolve, result get. Since we know that this is a unique index, we know that it'll have exactly one result if that collection is not empty. All right. Yes. ID index. Oh, can't use that anymore. Duh. Already re-implemented that part. It's like, this looks very familiar. All right. So if the ID index contains, no. I should probably do contains. But I kind of need to create the other key. I need to do these in a weird way. Yeah, I think this was probably not a great idea to replace the tree store, because I just don't have all of the implementations yet. I mean, I could do this in an interesting way. Public Boolean contains. This is going to be key parts. So by that, basically, I already know the keys or the fields that I have. I'm just going to slam it up into the same values. So if I did contains the key parts, I need to create a key with a record. Oh. All right, so what if I did a create key with the key parts? Now, I guess I don't need to worry about that. I do need to, I need to make sure that it's the same size, right? So key parts, not equal, if key parts is the length is not equal to fields size, throw a new illegal argument exception. And I bet that's a list only. All right. Yeah, that'll work, right? So back over here, instead of doing this, that is really dumb. I need to do contains on the ID. Right? So then why don't we do the same thing? Yeah. So then my index. See, this is going to be difficult because of the fact that it's possible that it's going to have multiples. But I know that it's a unique index, so it should be fine. I wonder if I should just have certain methods available for unique index and not on the other. Yeah, I should probably do that. Size. That one should be fine. Let's come up here. Unique index. And here. R. Sure. Let's just throw some crap together and hope for the best. All right, so then we don't have to do the other get. Don't think I, yeah, I didn't do it on that one. So unique index. Do I really need that? Tree dot get this, right? So that's just delegating through, and because this is a unique index, I'm not worried about the having multiples internally. Oh, this is a little bit different. Does not exist. So this one I would have to find it first. Nope. Remove. Yeah, that should be right. JS object. Oh, this is because it's expecting something to be returned. There we go. Song sounds familiar. Sounds like a copyright violation. But it shouldn't be, because it's string beats. I don't know. That might work. Oh crap, it is 2:50 p.m. I'm gonna have to run. Alright, found duplicate key. Alright, well, it does look like unique key constraint. Where did it have the problem at? It's because this is internal. Existence store. So this is put. Oh, I didn't actually remove it from the old index first. That's a little bit different. I'm surprised that didn't fail. All right, so if the I think I got that wrong. If the store contains the key, why is there a not in front of that? I think this is remove from indexes. Yeah. So put. Yeah, I need to remove it so that I can re-add it as the new object. Previous. So we need to remove the previous. And then we need to add the new one because it could have a different revision ID or different values in it. And this one should be fine. No, it's not fine. Found duplicate key still. Does not exist. How is that getting a duplicate key if it doesn't exist? Well, let's breakpoint. Actually, let's instead of that, we should pause on that stuff. All right, so here we have this guy. Let's look at the call stack. We have the B tree, we have the unique index, we have this lambda. So the JS object that we have here is Alex and 4. So Alex is the ID. And let's look at the ID index. Yeah, this is not pretty whenever it's where it's all in the JavaScript side. I might have to debug my B tree. So that maybe that's where we will join back in whenever I stream next. I do have to end it for today, unfortunately. We did get quite a lot of stuff done today. Not as much as I would have hoped, but enough to get us by. Yeah, whenever we come back, I'm gonna have to figure out why the ID index tree is not building appropriately, because I'm seeing that it's not containing this ID, but then whenever I try to add this JS object, then it's failing, saying that it already exists. So that doesn't make a lot of sense to me. So yeah, so we'll do that whenever we come back. I don't know when we're going to come back. I know that tomorrow is Wednesday and Colin might be streaming. If he doesn't, I'll try to stream tomorrow. Otherwise, it'll probably be Thursday. So have a good one. Bye.